Hello everyone, welcome to this tutorial. My name is Shijhei. We can know through a short study, machine learning is an important part of artificial intelligence. Artificial intelligence can help us better monitor the Earth environment and classify and process data. We will be coding Python today using Google Colab, a platform that is very available and free for us. Its GPU resources need not be installed, just click the connection in the top right corner to start running. Okay, now we start to get into the main topic. First of all, we open Google Browser and then log in UCL Moodle to enter the content of the AI course. Find the content connection of week 2, be sure to download the required files in Google Drive, and then enter the Google Colab. First, we need to click the Connect button in the upper right corner to start our conversation, and then click the first Run button to mount your Google Drive to it. At this time, you need to sign into your Google account and click Agree, and then we go down. We can see a string of code in which the variables x and y represent our data points. We use the linear regression model in the scikit-learn library to fit our data. The blue dots represent the actual data points, and the red lines are the predicted trend lines, or the best fit lines. This code belongs to linear regression, which is a form of supervised learning, meaning that the model is trained using labeled data. Moving on, the code below belongs to clustering, which classifies each point according to its characteristics. K means clustering falls under unsupervised learning. Here, the algorithm works without labeled data, identifying patterns and grouping data based on similarities. Think of it as discovering natural groupings without any prior knowledge of categories. We can see that the original definition is divided into 4 categories. We can change this at will. Like I now give it a new instruction, let it divide into 6 categories and then rerun or come out with a new graph. If we go down and continue, we can see that 4 images appear, which represent overfitting and underfitting. So at this time, we need to choose the model to prevent overfitting. I found relevant pictures in the courseware. We can see that the leftmost picture is the underfitting curve, and the rightmost is the overfitting curve. The ideal result we want is the middle effect. Let's repeat our previous preparation. First connect the GPU, and then click the Run button to mount our Google Drive on it. Through the explanation of the previous part, this part should not be too difficult to run. The only thing to note is that we need to change the path of some files. I'm going to talk about this part as we run through the code. Sea ice leads are fractures in the ice that play a crucial role in climate systems and marine ecosystems. We use data from the Ocean and Land Color Instrument, OLSI, aboard Sentinel-3 satellites, capturing imagery across 21 spectral bands. Let's focus on understanding what this piece of code means. In this case, because we need to use multiple pixels to get the data, we create 3x3 pates, making sure that each one has 21 bombs in it. And finally, when we run all the code, we have to make sure that we save the current file. In this case, we change the save address to our own, and then we can run it, and at the end of the run, the file is saved. Now for the last part, let's repeat the previous steps and click the Run button. It's worth noting that we also need to make changes to the path of the file. We look down, and we can know the convolutional neural networks. KNNs are a class of deep learning models primarily used for analyzing visual data, such as images and videos. They are designed to automatically and adaptively learn spatial hierarchies of features from input data, making them highly effective for tasks like image classification, object detection, and more. I'll take this convolutional neural network code as an example to describe what it means and how it works. This code defines and trains a convolutional neural network code for a binary classification task using TensorFlow, an open-source machine learning library, and Keras, a high-level API for building neural network. A sequential model is used, stacking layers in order. The model includes a convolutional layer with 32 filters and a TUX2 kernel for feature extraction from a 3x3 image with 21 channels, a pooling layer to reduce spatial dimensions through max pooling, downsampling, a flattened layer to convert 2 feature maps into a 1 vector. For classification, a dense layer with 64 neurons and ReLU activation adds nonlinearity. A final dense one, layer with a sigmoid activation, outputs a value between 0 and 1 for binary classification. The model is then compiled and trained on the dataset. Moving on, we'll see the Vision Transformer model. Vision Transformer, VIT, is a deep learning model introduced by Google in 2020 that applies the transformer architecture originally designed for natural language processing, LP, to computer vision tasks such as image classification. Unlike convolutional neural networks, CNNs, which rely on convolutions to extract spatial features, VITs process images as sequences, just like words in a sentence. We can see that there are several confusion matrices like this just now, and we will take one of them to explain. We will use a calculation formula, where TP is the parameter in the lower right corner of the picture just now, FP is the parameter in the upper right corner, the parameter in the lower left corner is N, and the parameter in the upper left corner is Tn. We calculate its accuracy through this, and obviously the accuracy of my side is 87%. According to verification findings, K-fold cross-validation is a resampling technique used to evaluate machine learning models by splitting the dataset into multiple subsets. It helps prevent overfitting and ensures that the model generalizes well to unseen data. It works by first randomly dividing the dataset into K equally sized folds. The model is then trained on the K1 fold. The remaining 1 times is used for verification. This process is repeated K times, with each fold serving as a verification set. Finally, the results of all K iterations, accuracy, recall, etc., are averaged to obtain the final evaluation.